That's correct. Hello. Hi. Nice to meet you again, guys, for joining my training. Today, we have the topic about all the details about cylinder head gasket, especially the metal layer steel gaskets. Wait a second, because the topic of the day will be like this. This is what we announced in the flyer. So today we check really what is the need for the new engine types, the cylinder head gasket, what is the stopper meaning, what is the function, what is the job for a sealing bead, half bead, full bead, what's the difference, where's the location where you find this kind of sealing solutions on a cylinder head gaskets. So all these kind of facts we want to check out today, and I will also explain you a little bit, okay, about engines in general, how they changed, what was in the past, what is nowadays, what's different, what we have to achieve nowadays as a gasket manufacturer to fulfill all the regulations, and also to explain a little bit what a stopper design means, what a function it is. And I have also some, I would say, some Chinese gasket comparison against our OE and aftermarket gasket. That's maybe also interesting to see difference, and I can explain really what is the difference between the gaskets. So some words about me. I'm from Kitzbühel. I'm a technical trainer for earring now more than 6 years. So I'm doing training, what you do now as a webinar, but I also arrived today back from Serbia. I was running all spots in Serbia, all big cities to do trainings 2 in a day. So it was a stressful week, and today we have finally the webinar. So I'm happy to present you now for 1 hour the latest gasket technology. So the introduction about earring, it's quite fixed. So I think some of you knows it, but we are founded in 1879. We are spread worldwide, 46 production sites. We are roughly like 10,000 employees and 1.8 billion turnover we create every year. We are still in the hand of a family called family Lechler is the name of the family, and this is the big shareholder of the company. So since 1920, we have the experience of mass production for cylinder head gaskets. The first car was an Opel Frog, 9 horsepower. Since 1994, the technology changed to metal layer steel gaskets. There was a need for bending and punching metal, and then we joined, or the part of the Klinger company joined earring because they had the knowledge in those times. And since 2000, we are a stock traded company. And since there, we have a big research and development department for all new stuff, what we're calling this like e-mobility. It could be hydrogen, could be also battery and drivetrain systems. So in our area, we're also growing. They also announced now the latest news in our latest plant, Neuffen. This is also where the aftermarket, so it means earring is located. We have now the green light to build up bigger production sites. So we're investing 2 digits of millions to create more production sites. So it's a clear sign for us that we are growing in Germany. That's fine. But the headquarters is also not far away. This is in Dettingen-Elms. There is located the CEO board and also hydrogen production and research and development, but also all passenger cars, cylinder head gaskets, what's necessary in our region, and also all the heavy duty stuff like trucks. Plant 2 is for plastic modules. This is also what we are producing, what we are creating. Plastic modules means it's inside in the car, clear. Everybody knows a valve cover, everybody knows an oil pan, but also some parts like in front of a spoiler, underneath, shielding technology made out of plastic, could be also inside in the door, could be also a dashboard, crossbar beam. So something like this we are creating in a big amount, and the turnover nowadays in plastic lightweight components is higher as cylinder head gaskets. That's a nice fact. So difference between the OE gasket, I would say, and the aftermarket, there's nothing. Quite easy and quick to say. The only difference what you will find on a gasket like that is like the coat what we put on with a laser spot. So the laser spot decides if the gasket is going to the OE or it's going to the aftermarket. The rest of the gasket is identical 100%. So you can trust in the earring products is the same what you will find also in the first equipment in the car. So it means if you open up and you find EK, KLG or RK on the OE gasket, then you know it's coming out of our production sites. We produced via OE supplier, OE manufacturer. So it means this is a gasket from us. The aftermarket gasket has our nice frog, how we're calling this, the earring logo, and our 6-digit number. So what we are doing is like all the products what you need in the aftermarket, means from special gaskets, the cylinder head gaskets for sure, right? Matching bolts, sealings, then also valve covers nowadays, oil seals, and we have a big bunch of sets. So the first car I mentioned to you, was that one. In those times they used copper and asbestos. Nowadays we can use in this kind of heavy car like the composite gaskets, like made out of composite and fiber. But nowadays we changed to metal layer steel gasket, and this is what we're doing the focus today straight on. So that means we are producing 42 million cylinder head gaskets, MLS gaskets, only for passenger car worldwide a year. So that means the total amount of new cars every year is 80 million. So you can see like more than 50% is coming out of our production side. So it means the shares of the market share, we are more than 50%. So it means every second car is coming with our gasket. So that means this is, the high trust in our product and our technology. And later on, you will understand why and what we are doing inside in a gasket like this. Still, there's 3 different kind of gasket types, what we are producing gaskets. So we have the composite gasket, how we're calling this metal soft material gaskets. We have the Metalloflex, what for us is the MLS gasket. Metalloflex is a brand name. And the metal elastomer gaskets are for the heavy duty stuff. So that means this is really only used in heavy duty parts. So doesn't matter what kind of gasket we have. We want to have requirements. It means it must be gas, coolant, oil tightened, should be retardant free, flexible, torsion free. We have also a clear lifetime definition. So it means 250,000 kilometers is our expectations for a cylinder head gasket. But today, lucky as we are, anything around in an engine, it's breaks down earlier. That means you have a need to open up an engine. You as engine builder knows better than I do. So pistons, liners, whatever, valves are broken, and then you have to replace in that way either the cylinder head gasket. So what is the job of a cylinder head gasket is to control the movements, of the head against the block. And these movements, we have to handle it. So we have to eliminate the movements we have, but still we have in focus our sealing job. That means we have to seal about any kind of liquids and gases inside. So in the past, that was the technology what they used until 1994. Let's say something like this. We still produce this kind of product. It means the composite fiber material. It was in those times a good gasket technology. It had also some defined lifetime, I would say, like roughly like 100,000 kilometers. After this, you had the first science for a kind of a cylinder head gaskets fault that you have to change it, because otherwise, if you don't change it, the oil and the coolant are mixing together, and that is what you don't want to have. So in this case, they use this kind of sealing technology. This is the need for the roughness. If you repair the gasket, the cylinder head gasket, yes, there's in those times was okay to go with some grinding paper over it and clean the surfaces. It was crank cast iron blocks, but nowadays it's a little bit different. Give you an example. The latest gasket, what it was used, was in an, for example, was in a Volkswagen GTI Mark III. So this Mark III in those times, and this is really the high performance output. It was one of the latest in 1994, 1995. There was the power like 150 horsepower, but this was a 1612 version out of it. But the normal GTI had 112 out of 2 liters engines capacity. So to give you the feeling, those kinds of engine was natural aspirated, so it means no turbocharger, classical setup, 16 valves, and horsepower was quite enough. In those times, also this engine has a kind of movements. This what I show you in this kind of simulation. But in those times, it was okay to use this kind of sealing technology to handle this kind of power. But if we are going now some years further, so it means now if we go check out the latest GTI model, so this is the Mark 8, actually what we have. There we are not speaking anymore about 150 horsepower. Nowadays, out of the same capacity, like 2 liters, this version is like 310 horsepower. So that means like we double up the power, and for sure clear, this is not possible anymore to handle with a classical composite gasket. Why? Because the movements increased and we need nowadays a high flexible gasket. That means the gasket has to eliminate movements. We have defined sealing spots. We not have any more overall sealing technology, what it was in before, like the composite gaskets. Nowadays, we have a line sealing function. What does it mean? You will see later in detail. But to give you the idea, nowadays, everything is getting more horsepower, but the capacity of the engine stays like the same. So this is like really, but the benefit also for the newer engines today, it's like the consumption is going down, fuel consumption, efficiency is also getting better and better. So if you compare really, like I would say the last 30 years, then we have really made a huge step in front. But for sure, that nowadays these engines, what we have, they are no more so robust, I would say, as it was before, because material changed, added more parts, turbochargers, HER valves, and so on. A lot of stuff what is necessary to have a clean and a good engine, but also still a high output of power. What does it invent? It means the engine blocks must be lighter, they must be smaller in general. So also if you compare cylinder head gaskets from the past to this, what it's nowadays, engines getting smaller. So it means from the length side. So it means like the cylinder liners getting closer to each other, and the barriers in between of the liner walls are getting closer together, and sometimes they are sharing one spot for a bead. In the past, it was enough space to have 2 round beads. Nowadays, you have 2 beads, they are coming together, and then you have one line in between. And this is a high risk for any kind of failure if you are overhauling surfaces like that, so like milling and grinding, that you have to really take care that it's in good conditions. So as I mentioned, engines getting smaller, aluminum silicium engine blocks came up. The engine design as itself changed. As also you can see here in the picture, and later you will see also more pictures about the design of an engine. It's now getting an open deck engine because you want to cool down the whole block in a good way. That means the highest point in general inside in an engine on the piston side, it's on top. There's like 300, or no, it's more than 300 degrees. But in this kind of temperature region, there you want to have as much water as it is possible to cool down the parts as quick as it is, or stays in the same temperature range. And this was the idea to open up the deck, to make open deck engines. And the open deck engine has the benefit that the water is getting up to the top position to cool down everything. So this was one point. The other point, we are also adding now, or more or less like now, every kind of new engine types, they have turbochargers for sure, because so you can increase easily the output of power with the same capacity, and can also reduce the consumption of fuel. So this was also coming up, and that means also now the temperature around of the cylinder head gasket increased dramatically. So the material as itself must be also nowadays more heat resistant as it was before. So coming back to this open deck design, the open deck design has some good and some bad benefit, depends a little bit what kind of engine type it is. Here in my example, we have very thick cylinder walls, so it means like it's a thick version out of it. The walls are, or the channels are open until to the top, so the water can really flow until to the top position and cool down everything. So, but the other point is also aluminum silicium engine blocks, they need a special preparation, especially for cylinder liners, coatings, honing, and so on. I think Rainer is the motor expert as I am. And I'm pretty sure he told you a lot of stories about the right point of honing. But inside you have these silicon crystal surfaces. That means like if they're getting, or yes, the honing process, and as also Rainer mentioned to you, there you need a special honing stones where you have to open up the stones, the silicon stones, that they are working like a lubrication part inside in the cylinder liner solution. The other point is like this plasma coating stuff. So there is more or less like no possibility to hone this kind of point. There you have to go for cylinder liners. And if you go for cylinder liners, especially in open deck engines, then you have to take care if you take the completely liner out and replace it to any kind of other solution. There exists a lot of different kind of stuff. But yeah, this is another story. Coming back to our cylinder head gasket, I told you we have some special things inside in the gasket. I told you about beads, half beads, full beads. What's the difference? Before we are going so deep in detail, I will tell you what kind of material do we have. So this is a high flexible steel. It's a spring steel, and this flexibility we need because we punch during the process of the production of one layer, because we produce layer by layer, and then later we collect all the layers together. We punch in this function layer, how we calling this. We are punching there a bead inside, a deformation into the metal. And the deformation stays as it is in a high flexible range because the material as itself is flexible, and then the bead is working like a spring. You also see the color is, in our example here, is a golden color, and the golden color is not coming from the material. The golden color in the beginning, or more or less the spring steel, looks in the beginning silver, like normal steel, but then it turns into golden because after the first production process, if you're punching out the holes and putting the beads inside, the material gets a lot of stress, and we want to release the stress because we need this flexibility inside in the material. And so we put this kind of metal sheets inside into an oven. We're calling this a heat treatment process. And this heat treatment process takes like roughly like 30 minutes, like for 300 degrees Celsius. And then the material relaxes, the molecules going back, and we have still the high flexibility in the material. And it's a big benefit, and we need this, that we have a long-lasting good sealing solution. So this is the reason why they're turning into the golden color. This is not a spray-on color. This is coming from the temperature. So in the middle, you have the carrier layer, and the carrier layer decides how thick a gasket will be. You can also stack up more function layers, then you have more and a higher spring version inside. And the function layer inside integrates oftentimes also some sealing technology, what we're calling the stopper. But later I will tell you more about the stopper in detail. But this is located not in the same line as a bead, it's behind or in front of a bead. It's never directly stopper function on a bead. So here on that side, this is a set. You have to imagine this is a set. It's only a half bead, and half beads are used around water and oil jackets in the backyard of a cylinder head gasket, because there it's enough to seal low pressure and coolant and liquids with an half bead, how we calling this. A full bead is necessary to seal up in the gases. This is like a U shape. It's going up, going down. And very important to mention also here in this kind of sealing solutions, we have a line sealing function. That means we are not sealing anymore everywhere around the big thick surface as we had in the composite gaskets. Now we have only a line sealing function. Later we will also see what does it mean. So yeah, these are the sealing beads. We have the stoppers, we have the half beads for the fluid sealing beads, what's coming here around on both sides for sure, because on all function layers there it is. And as I told you, we have a sealing line, and to show you what does it mean, a sealing line, there exists I would say a test what we are doing also with our cylinder layers. When we are producing them, we want to know how good the sealing line is working. And we're doing this with a blueprint test. That means like this is like a Fuji pipe. We put this in between of the gasket and doing a blueprint test. We press this together, and where we see a deep blue, or in general blue color, there we know this was the sealing line. And we want to have a closed sealing line, as you see here, deep blue color. If we have some spots, they are open, they are light blue. This is what we don't want to have, because that can be causes to some defects. So this is how we are checking our products, that we are proof that our gaskets are work in a proper way as it should be. So there exists different kind of tests, different kind of layers what you want to try, and then based on this you can see in an example how this kind of blueprint test looks like in the end. This is a This is a test out of our production, so it means this was not fitted into an engine. This is going into a hydraulic press. We put our one layer of out of the production inside. We put the paper in between, the blueprint paper, press this down with some tons for some seconds, release it, and then we know, okay, if they're punching together, this is like the line where we have our sealing function. So around of a cylinder head gasket, you have not only these full beads and half beads, sometimes it exists also some backland support elements. They are also necessary because sometimes heads or more or less like points for the cylinder head bolts are located in some spots, and the high risk could be that you are tightening down in a U shape your head, and this is what you have to avoid. Sometimes these backland supports elements, they are located outside, that you can really see, as it here in example, outside of a cylinder head gasket, but they can also be inside in a gasket, but it's not visible for you to see. But where and who we are doing this is like based on our experience, because before we are more or less like make the development of gaskets, we have test benches where we are testing how the gaskets are behaving, how they are working, and where they have some weak points where we have to improve. And based on this kind of experience, what we have, we can create the gaskets that in the end they are working for a long-lasting sealing technology. Then also you see double stoppers. In general, what a stopper means, I will show you later, but exists also some gaskets, engine types, they need a double stopper because this is also a seldom version, but exists, for example, diesel engines, they have high power and they need oftentimes more than only one stopper. Gasoline, small gasoline engines, they have not so much movements. It's all the time based on the movements. Also, a direct stopper sealing technology also exists, that the stopper is not located away from the stopper, from the bead. It could be also direct on it. And the other one things is also what you see is the slotted layers. So it means like we have some decoupling bore sealings, that it means like that we can remove movements out of the cylinder head gasket. We have reduction of relative movements between the gasket and the engine components, and we can also have a reduction of wear and freezing of this product. So you see, you cannot speak in general. I can only tell you what it exists in gasket. It depends really what kind of engine it is, and based on that, we are choosing the right cylinder head gasket for it. So what kind of stoppers did exist? There exist a lot of different stoppers because it exists also different kind of engine types. So it could be a simple stopper, it could be a more complex stopper, I want to say. Depends a little bit about how is the production process, how much we will invest in this kind of gasket, what is the need for it. Do you need a folded over stopper version? You also have the solution for welded stopper. That means a ring around of the combustion area will be welded in. This additionally production process, what also means from the cost side, it will increase the costs of a gasket. And if it's really a critical sealing function, then it's a direct stopper sealing function on the bead. This is like this example. The other point is it also exists the coin stoppers, and the coin stoppers gives us more options for any kind of features to improve a cylinder head gasket, that it works in a better way, in a safe way, that it works like as it should be. So that is also one possibility with the honeycomb stopper, what I will also show you later. What does it mean? So it exists not only one layer gaskets, because we have said it's a multi-layer gasket. So for sure, it also exists small Fiat engines, Fiat 500. They have also one layer cylinder head gasket, also exists something like this. But mostly a cylinder head gasket made out of metal are existence out of more than one layer. So it's a multi-layer gasket, 2, 3, 4, 5. Depends about the cylinder head, the engine characteristic what we have. So it also double stopper variants. What I also mentioned, it could be, as you see, it could be inside in the function layer. It could be also integrated in the center layer. It could be in both. So there's a lot of versions around it. Also the direct sealing variation, and then we have also multifunction layers that we said we have not only 1, 2, 3 layers. So we have also more than one function layer inside in a cylinder head gasket. It could be 5, 6, 7 layers, depends really about the engine type. On top, you see the color. You see red and gray. It also exists blue colors and so on and so on. The color is a coating, and this coating is a kind of a silicon coating. Why and how do we need this kind of screen printing? How we're calling this? This is necessary to grab the gasket into the surface of the roughness of the block, because this is essential. This is necessary that the gasket can, on one hand side, seal a little bit the roughnesses of the surface, because otherwise pure metal on metal will not have a good sealing effect. So we're adding a kind of a silicon, and this is grabbing into the surface and keeps the gasket in place. The best way will be if you remove an old gasket out of an engine, that this kind of coating is more or less like gone, and you get some golden spots. If you see golden spots, that's a good sign, because then you know, okay, the gasket was grabbing into the surface and keeps the gasket in place and made a super good sealing job. So coming back to our stoppers, what the stopper is also doing, he's supporting the metal, the function layer, about this vibration, this movements, what we have. If we don't have it, and you can see here in the animation that the function layer has more or less like more possibilities to lift up, and then the time is limited. A nice example out of it is like if you take a rubber band, and this rubber band, you spread it until to the maximum all the time. You do this maybe 10, 15, 20 times, and you spread it really to the maximum, and maybe after 20 times, it breaks into pieces, because then the material was so stressed that also a rubber band, which has normally a high flexibility, will also fail. And to avoid this kind of function, we said, okay, we have to limit it, how far you're pushing away this rubber band. So it means if you go only to 80% instead of completely 100%, then it saves more or less the lifetime of the material. And you can do this much more than 25 times. You can go for 150 or 250, whatever, okay? And this is the same function for a stopper. That means the stopper is also limited the way of the function layer, how they are working. And there exists also different kind of stopper variation. What I said, it exists stiff stoppers, it exists high flexible stoppers. One is allowing more movements, the other one is allowing less movements. So in this case, depends really again about the engine characteristic. What do we need? A stiff stopper is like a honeycomb stopper, as you see here. This has like this coin stopper variation. We have different kind of things, what we punch into the center layer, or could be also function layer. And a serpentine stopper, it looks like a serpentine. That's the reason why we're calling this. This is a high flexible stopper. This allows a little bit more movements. So I think this was the same. Okay. What we also have is we have to handle also the stiffnesses inside in the engine part, because sometimes some parts in some areas more stiffer because we have more material in behind, but sometimes could be also happen that we have water channels in behind, and then you have less material and you have less stiffness in the engine parts. But we have a round surface, and we want to have in all spots like the same sealing function, and then we have to handle it, and we have to look what is the solution for it. How can we handle it? What is possible? Also on the opposite side, it means also, as I told you, this is again the design of an open deck engine block. We have thin walls, and the thin walls has all different kind of stiffness, and this we have also take care that we have a proper sealing application around of the cylinder liner surface. So what also happens if you tighten down the bolts, then the deformation of a cylinder happens, because you have 4 fixation points of the bolts, and these 4 fixation points has a high force next to a bolt, and this creates also a deformation of your cylinder liner. This is the one hand side. The other side is, as I told you, we have a line sealing function. We want to have the same pressure in every spot, so that we can have the same pressure in every spot. This we can also do with a Fuji paper. We can see, okay, how is the line test. We tighten down the bolts, because normally, as you see here in the example, next to a bolt, you have a high pressure. So it means now it's turning from blue into red. And if it means it gets dark red, then you know, okay, there's a good sealing function, a good pressure on the part. But if it's getting lighter, brighter, then it means like here is less pressure. But we want to have around of the combustion area, and it doesn't matter also in the backland. We also want to have everywhere the same pressure. And to lead this same pressure, we can do this by a topography in the stopper. What does it mean? So it means like in the spots like 12, 3, 6, and 8 and 9 o'clock, we are going up with the thickness of the layers of the stopper. And in the areas where we have enough pressure, we are going down. So it means next to the bolts, we are going down. And next to the bolts means like we're getting smaller with the thicknesses of the gasket. And so you have a waviness inside in the stopper. And this waviness is necessary, or more or less like it's integrated. You cannot see it, you cannot feel it. But this is what we are doing because we are talking about micrometers. Here is a real example out of this topography of a stopper. You see, not everywhere we go up, but it exists some spots there's a little bit lower, some a little bit higher. This is also based on our experience and on our tests, what we are doing. So the tests, what we are doing, that's a good point, because I have also an example out of our testing. That means like we can also take a look, okay, how good and how is the pressure on a sealing bead. That means like we have there some measurement methods where we can really see, okay, how is the pressure working also in different kind of temperature situations on the head and on the block. So it means also on our cylinder head gasket. And there we are checking not only one bead, we have, as you see, we have half beads. They are running here around. We have stoppers, inside and outside stopper elements where we are measuring. We have full beads around, and all these kind of spots also here around these boreholes or these holes, what we have here. There's also a half bead, which we also have to take care that the coolant and the oil is not leaking. So this is like also how we are checking our gaskets, that we can prove and we know, okay, this gasket works for a long time in a proper way. So a real test what a customer that did for us was in the US, because they checked inside in their facility. There's also a big engine rebuilder shop. They are doing a lot of V8 engines for sure. And they had some issues with the head gaskets, and with this head gaskets, they was not satisfied with the quality of their supplier from head gaskets, and they said, okay, we will check out how good the airing stuff it is, and they did this kind of test by themselves. So it was not paid, it was not forced from our side, and we received the pictures that, hey, this is brilliant, this is a good example to show also other industry colleagues what does it mean, a good and a not so good gasket. So going details, you see our gasket was really like nice as you can draw by a pencil, a red line, a constant good sealing spot. And the competitor was, I would say, it will work for sure. This is not a point that we say, okay, this gasket doesn't work because you have only white spots. No, but that is more or less like one of the reasons why they had this trouble and why they want to change, because there's a high risk. And you know, in the US, if they're giving something for customers, then they want to have warranty, and they came back, and so they have to pay and lose more or less like a lot of money, and then they go on the safe side and said, no, we want to avoid this kind of situation, and so we are going with another gasket type, and then this problem is solved forever. So this was really a nice example. Here's also an example out of the Fuji paper stuff, because oftentimes people ask me, okay, what is this for paper? Who is offering this? I also want to have it. Fuji, it's from Fuji, really easy, called Fuji paper. And as you see, there's also the color intensity. It means like, as I told you, how more darker it gets, or how much pressure you have on the line. If it's lighter, brighter, then you have less pressure. So everybody can go for this kind of test. So this Fuji paper is available on rolls, and so you can really go if you like with this kind of test situation. The next time, if you have the feeling you want to test by yourself, if everything is done in a good way, so there's no problem, you can go for it. But also gaskets can fail, that's for sure. Also beads can break. There's sometimes reasons for it, and the reasons means like there's something happening that you allow the gasket that have more movements as it should be, and the more movements means like that the gasket, or more or less like the stopper, can lift up and down without the support element. And how can this happen? This can happen if the surface has a distortion inside. And mostly it's like that some guys are using old bolts again. So this is still where I came from Serbia. They have the attitude, they're wondering that really we need new bolts all the time. Yes, you need. Don't save the money on the bolts because the bolts are essential. They are stretching bolts, they're one-time usable bolts. You cannot use it again, and this is really a benefit because otherwise this is also, it doesn't matter which kind of brand of gasket you install, it will not have a successful long lifetime. The other point is also what I told you is about the thin walls in between cylinder liners. That means like here is reacting on and working for sure our bead, and this is okay, but they're sharing, as I told you, one thin material of metal, and this is also aluminium. And what it happens all the time that you have this groove building situation because you have aluminium against spring steel, is a hot steel, and they are working inside into the surface. So that means like you have these spots, then you have, I think you as engine builder, for sure, you go for milling and grinding all the time the surfaces. But this is all really essential that you check really that you're on the safe side. These spots are in good conditions. Otherwise, if you put the gasket inside and you have blow-by gases, then creating a bigger problem, because not the gasket is not a problem anymore because it's cheap. But if you're burning parts away from your head or your block, this is really what you don't want to have. So in this case, be careful. The other example, it is like here, as I told you in the beginning, we have this golden spots. This is a used gasket. This is normally what you want to see on a used cylinder head gasket. If you open up an engine, you see the old gasket and you see, okay, the coating is more or less like gone. That's a good sign. You see the golden spots, then you know, okay, the gasket was working into the surface in a proper way. So that is fine. So this is really what you want to have. If you see still the coating on the side, then it's a sign for you, okay, hey, something was not okay. There's a problem because it was not in a good contact. And then if you see rainbow colors, it's a clear sign that gases are blowing by, creating some overheating spots. And this is really, what it's difficult. So, and now I have some examples out of the BMW world, because out of that, I can also explain to you a little bit more details about cylinder head gaskets and also about BMW stuff. This is an example of the S55 and N55. There are two engines. They are not identical, but the S55 is based on the N55. BMW invented in the N55 a new design, a new idea how to build up an engine. It turns out that there was some parts what you can improve, what they had improved based on the S55, because in the beginning the N55 was an open deck engine, and the open deck engine has, as I told you, a good benefit that you get the cooling up to the top. This is great that you can cool down, but on the other side, especially with the 6-cylinder high performance engines, you limit it more or less like the lifetime from one hand side, but also the possibility to improve the horsepowers by the stiffness of a block. So these kind of guys who are using N55s, they like to improve the horsepowers, and based on that, they have sometimes then the trouble with the open deck engine design. So that is also one of the reasons when they made some modification on the S55, they did go back to a closed deck engine block, as you see here. So they're closing again the engine block. That means like the engine block gets stiffer. There was more possibility to get more horsepower out of it, and this was one big change of the technology, more or less like between N55 and S55. They did more about oil pan and oil pump and so on and so on. But this is really on the focus on the base view of an engine block, really the detailed stuff. So if you check the cylinder head gaskets, and this is also a nice example because this is also what I promised to you, we will compare also competitors. As you see, the silver one is not from us. In those kind of application for the S55, we are not the OE supplier. This is also what BMW is doing all the time. They changing all the time the OE supplier from time to time. Also on the engine base. So they said, okay, for one lifetime, like 5 years, we go with this supplier, and then we change to another supplier. But also, as you see, heat treatment is for everybody a little bit a different kind of topic. So the topper gasket is a little bit brighter, it's more silver. Ours once is a little bit, I would say, more goldy, shiny, looks like. But in the end, this is only a small fact about it. So the other point is how they design gaskets, and this is for everybody difficult to see what is inside in a gasket, what kind of stopper do they use, what kind of coating do they have. And this is like what we have the experience. We are able, or we are open gaskets. We know what is inside, especially if you take a look here. Then you see also the difference in the colors, because on the left side is like the competitor, and this is our golden color. And there you see really the flexibility is more given in the golden color as in the silver color. What does it mean in the end of, if we have a higher flexibility, then it's able to handle longer and more movements of the head against the bead. So both are working identical with laser spot stoppers. This is like what you see here inside. This is the stopper technology. It's inside in the function layer. So it's laser welded inside. They're using the same technology, so they are identical. And now what you see, and this is also interesting to tell you, you see now everything is black coated. What is necessary all the time that you have against function and center layer a coating in between, because that's a kind of a sealing function, because you have also seal in between of the cylinder head gaskets, and this is necessary. So that means you can coat the inside of the function layer, or you can completely coat the center layer. And oftentimes there's coated center layer completely black on both sides, and the function layers on the bottom side are not coated. So another example is like if you're flipping up more or less the cylinder head gaskets, then you see it's not only one layer, there are 3-layer gaskets, and they have also on the opposite sides not a welded stopper anymore, because there's only a pure bead. What you not see here in this kind of cylinder head gaskets, there's less support elements, so it means there's not necessary to support some spots. This is in this kind of engine type not really required. So I have now an example with me, and I hope you can see it. Otherwise, I have to remove a little bit the virtual screen, because I have now here 2 gaskets. I have to remove it. Give me a second. Go away. Wait a second. None. Okay, perfect. So these are identical gaskets. They are with a 1.8 liter Volkswagen gasket. One is, I would say, the OE gasket, and the other one is I find it today. It was very funny on Alibaba. So it's a Chinese product. Okay, so from the first view, it looks from the color very identical. So there's also golden shiny, and this is the original. There's also golden with a gray coating. So they're both on the same level from the design. So this is right. But if you compare now the gaskets of the material, then I hope you can see it good with the camera. This is a little bit lighter. So the Chinese one, this one is not so deep golden as ours. It's okay. But also what the Chinese do, they do not a heat treatment, they do a color spray. So they use color to make it in a golden shine. So they have no idea why it's golden, so no experience about it. This is one point. The other point, and this is clear, and this is also, you see, I have this for a longer time. If you bend this material, then it stays like it is. It's not flipping back. If I do this the same with my gasket, from earring, it's going back. And this kind of flexibility is given by the heat treatment, and for sure also the material. So this is the one side. Okay. The other thing is, I hope you can see it here. There's the stopper. The stopper is located here. This is a honeycomb stopper. And this honeycomb stopper, this is not really in the same created good design. So in the thickness It's not, it's only a little bit here imprinted. It's out of the center. I would say it's not the best solution. But the worst thing in general about this gasket, and this is really the worst thing, it's like the rivets. You see these rivets? Rivets are not bad. We also produce gaskets with rivets. No worry about that. But the problem is the rivet as itself is located in this gasket inside in the engine block. So it means like here we have a sealing spot, here we have a sealing spot, but here there's also head and block. And I hope you can see it. The rivet is thicker as the whole gasket. How we do this with our cylinder head gasket? We have no rivets. This one is a folding system. So it means the function layer of the top is folding underneath of the bottom layer. So if you are pressing this gasket flat together and you're tightening down, then it's getting equal with the same level of the cylinder head gasket. So it's not a higher point here and here. And this is the more or less like the biggest mistake what the Chinese does. They use here rivets. If we using rivets, then the rivets are outside of the engine block. So it could be happen that we have rivets here in another engine gasket design, and then it's outside. So you can see from outside, here's a rivet, but never inside where you're tightening down a block. So I hope you understood now that pure from outside, you cannot compare gaskets. You have to know, you have to trust good brands, I want to say, brands with a name, brands where you know they are e-supplier. So then you're on the safe side to choose the right gasket. And in the end, you have a happy customer, because if they have not a successful repair and the gasket starts with leaking, this is what nobody wants to have. So I would say we are quite good in time.